Hello everyone. Hey guys, welcome to askIITians. This is lecture number 2 of area of triangles and parallelograms between same base and same parallels, right? So today we would be talking about a couple of more and more new interesting theorems on this chapter. In the last class we had talked about area of triangle between same parallels and area of parallelogram between same parallels. Now today we would be talking about the third theorem, that is, if a triangle and a parallelogram are on the same base and between same parallels, then the area of triangle is half the area of parallelograms. So far we had seen that if two parallelograms are between same base and same parallels, they are equal in area. If one parallelogram and one rectangle are between same base and same parallels, they are also equal in area. But now we are talking about that if one triangle and one parallelogram are between same base and same parallels, then the triangle ka area is half that of the area of parallelogram. This is a very important theorem. So if you consider this diagram, we can say that line L1 is parallel to line L2 and quadrilateral BCDE. So you all can see BCDE, it's a parallelogram, right? What do we have to prove? That area of triangle ABC, which is also between same base and same parallel, the common base here is BC, the height, the same parallels are L1 and L2 because the height is constant. So we have to prove that area of this triangle is half of area of BCDE, right? So we would say construct df as the height. Construct df as the height first. Okay. So after we have constructed the height, we would say now area of BCDE. Area of BCDE is base into height. Area of BCDE is base into height. Now the base is common, BC. Height we have constructed as df, right? Similarly, we would say area of triangle ABC, right? Area of triangle, this shaded triangle ABC, right? And this is your parallelogram. This is your parallelogram, right? So ABC, area of triangle, is half into base into height. The base is again common, BC. Height is also common in this case because L1 is parallel to L2. So height here will be DF, right? So area of triangle ABC is half into BC into DF. It's as simple as that. And area of parallelogram BCDE is BC into DF. So we can clearly see that area of triangle BAC or ABC is half of triangle, half of parallelogram BCDE. Very simple theorem, right? Without any confusion. It's a very basic thing which you need to understand, and we have proved it. Okay. Let's now come to next theorem, that is area of trapezium. So now we would be saying that we have to prove that area of trapezium, we all know this formula, we have learned this in our previous grade in mensuration chapter as well. So we would now be talking about area of trapezium, which is equal to half into sum of parallel sides into height. Height is nothing but distance between parallel sides, right? So we would say we are given that quadrilateral ABCD is a trapezium. We have to prove that area of this is half into AB plus BC. You have to prove area of quadrilateral ABCD is half into sum of parallel sides, that is AB plus DC or CD into distance between parallel sides, that is DE, right? So we would say construct BC, construct diagonal BC. Now consider area of triangle ABC. So we are finding area of triangle ABC, which is half into base into height. So base here would be AB and height would be DE, right? Because we have constructed that. Similarly, area of BCD would be C half into CD into DE, right? Now just add both these equations. So we would get half AB into D plus half CD into D. On the left hand side, we are getting area of smaller triangle ABC plus area of smaller triangle BCD. We know that when we add both these triangles, we are supposed to get a quadrilateral ABCD ka area, right? And that is nothing but half into AB plus CD into DE. Now AB plus CD is nothing but sum of parallel sides, and DE is nothing but height, right? So this is very simple, and this is how we proved that area of a trapezium is half into sum of parallel sides into height, right? So now let's quickly solve this question based on the results. So the first question is uh, area of triangle ABC, it's 27. You have to find area of quadrilateral BCDE. BCDE. Now it is given that EF and BC are parallel. You all can see in the diagram also they are in the same arrow. Whenever in the diagram these arrows are given, it implies that they are in the same direction, which means they are parallel. So BC is parallel to EF, which means the triangle and the quadrilateral, they both are between same base, so and between same parallel, right? So that area of triangle has to be half of the area of quadrilateral, which means area of quadrilateral has to be double the area of triangle, which means it should be just 54, right? Yes, that is correct, 54. So because they will have same height, as we saw, they are between same parallel and same base, right? This is according to theorem 3, which we just now studied, right? Let's solve one more question. Now this says this is a trapezium question, right? So here we have ABCD as a trapezium, quadrilateral ABCD is a trapezium, AB is parallel to CD. X and Y are the midpoints of AD and BC, right? X and Y are the midpoints of AD and BC respectively. We have to basically now find ratio of area of trapezium DCYX, that is the upper trapezium, the trapezium above XY, and ABXY, the trapezium below XY. So these are two trapeziums. We have to find the ratio of their areas. Okay, so we basically don't know what is the height of the given trapezium, but we know X and Y are midpoints. So if the H is the or 2H is the total height of the trapezium, then H is the height of above trapezium, that is XYDC, and H is the height of below trapezium, as it is shown in the diagram, that is uh, ABXY, right? This is H and this is also H, right? We are interested in finding the ratio. So you would say area of DCYX is nothing but half into XY plus CD, right? But do we have XY? So you would say first we need to find XY. How will we get XY? We will be using the midpoint theorem, which we have studied in triangles chapter, right? So midpoint theorem is nothing but ABXY is nothing but XO. See, in triangle ADB, you all can see that in triangle ADB, right, in this triangle, XO is half of AB because XO is the midpoint. XO is parallel to AB and X is the midpoint. So it bisects the third side, which means XO is half of AB. So AB is 60, XO will be 30. Right. Similarly, in triangle BCD, that is in this triangle, YO will be half of CD. YO will be half of 40, which will be 20. Right. So this would be 30 and this would be 20. So XY has to be 30 plus 20, which is 50. Right. XY has to be 50. Right. So we would be saying that XY is now 50. So we can now find the ratio of their areas. That is half into DC plus XY into H, half into AB plus XY into H, using the formula according to theorem 4, right? According to theorem 4, that is area of trapezium is half into sum of parallel sides into height. Height here is same because X and Y are the midpoints, right? So half gets cancelled, HH gets cancelled, AB was given as S. 60 and this is 50. DC was 40, XY is 50. So 90 by 110, which is just 9 by 11. So it was a very simple sum. If you just even look at the diagram, you would be able to get that question and get that ratio using midpoint theorem. So I hope you all understood this chapter, area of triangles and parallelograms between same base and same parallels. And one question at least of this chapter is asked, that is 3 to 4 marks in your final examination on the basis of these four theorems. So keep learning from us, Canadians, and thank you very much. Till then, stay safe. Goodbye. Take care.